All right, so obviously try it on your own first and then press play again. So stop this and then press play if you can't do it. All right, so you said that you're okay with angular speed. So this is number 4 from the review. So the Ferris wheel has a radius of 35 feet and it's 40 feet off the ground. And you said you found the angular speed. So you got the angular speed by doing 360 divided by 80. So that gives you degrees per second. Sweet. Okay? So B, write an equation that represents the height of the Ferris wheel in terms of t. Let me grab a calculator real quick. So at certain positions, it's really easy to find the height. Like here, if you start at the 3 o'clock position, you're obviously 40 feet off the ground, right? And then here, well, you know if the radius is 35, you're 5 feet off the ground. And so this is kind of key to helping us figure out the height, this 40. So we're going to work with that 40 and work with this 35. Now the problem is, what if you're at this position? So you notice I drew a triangle because with the triangle, we can use the triangle to find any height. If we're at a nice place, you don't need to use the triangle and the equation will take care of that. But if you're not a nice spot, right, that's easy to just calculate, we'll use the triangle to help us calculate the height. So how we use the triangle is, if you remember, SOHCAHTOA, if you have an angle, so if we can figure out what this angle is, sine of an angle is opposite over hypotenuse. So we have this equation, this function, that can help us. If we have all the other pieces, we can find one of the missing pieces. So notice, this isn't quite 35. That's 35. It doesn't go quite the whole way, but this is 35 always. So as the triangle rotates, that hypotenuse will always, always, always be 35. Okay? Opposite is why I picked sine. This is why and not cosine or tangent, is because if we can find that opposite side, we'll have the height. Even if we use a different triangle, we'll add it to 40 and have the height. And if we're over here, we'll then subtract it from 40 and have the height. Okay? So, super, super cool that triangle can do it, right? So, opposite is what we're going to solve for. So, I'm going to multiply by 35. So our equation for height, I don't know if that'll be in the video, so let's go like this. So part B, our equation for height at time t will be 40 plus 35 sine. Now we've got to put an angle in there, or then we need an angle, right? We need to figure out what our angle will be. So that's where you're going to use your angular speed. So 360 degrees divided by 80 seconds means that we'll do 4.5 degrees every second. So then we can plug in time, because B says make sure that it's a function of time. So by using, so let's say you want to find how high off the ground you are at 1 second, you can use 1 times, then we're 4.5 degrees. That's that angle. And we can use it on the triangle, on sine, to then figure out how high we are off the ground, right? So this is the answer to B, right there. So C, if you're to get on the Ferris wheel and it stops at 42 seconds to let more riders on the ride, what is your angle of rotation? So it's going away from that formula. C just wants to know, all right, so you're on there for 42 seconds. What is your angle? Okay? So if you're going 4.5 degrees per second, right? If we multiply by 42 seconds, then for every second, it'll calculate 4.5 rotation. So I'll do 4.5 times 42, and I'm going to get 189 degrees on C. And that cancels out, that degree stays, seconds are gone. Okay, so now D is how high off the ground are you at that 42 seconds? So we have two options. We can just put 189 degrees right in there because we already calculated what's going to our angle at 42 seconds, right? So at 42 seconds, you're going to rotate probably about there. And so there you are. So you can just plug 189 in there, or you can say 40 plus 35 sine 4.5 times 42. So it doesn't matter if you put in t exactly or just put in 49. So just gonna prove real quick how cool math is, right? So 35 times sine of 189 gives you a negative, right? Because it needs to subtract it from 45 to give the correct height, right? Or sorry, 40, not 45. So when I do 40 plus 35 sine 189, that's going to give me 34.52 feet, which makes sense. That's a little bit less than 40, right? 34.5 feet off the ground. Okay, if the rider stops again 50 seconds into the ride, find the terminal angle and then the exact sign for the angle of rotation. So it doesn't want to know the height. Nothing about the height. It wants to know if you rotate for 50 seconds, so you know that 80 is a full circle, so 40 will be halfway. So if we go 40 seconds, we're halfway. So 50 will probably be really close to where I drew that 42, right? It just wants to know what's that angle of rotation. How many degrees did you go? So remember, the same thing. We're just going to take 4.5 degrees per second and multiply it by 50 seconds. So seconds is gone. 4.5 times 50, 225 degrees. Okay? All right, so it says, find the terminal angle, then find the exact sine of that angle. You found the angle. Now, what is sine of that angle? So remember, sine of the angle is opposite over hypotenuse. So we already know the hypotenuse is going to be 35, right? Because we talked about that, how the radius is 35, and that is the full from the middle to the outside, so that's the radius. Now we just got to figure out that right there, okay? But if you remember, we learned the unit circle for the reason. So there's an unknown there, and this won't, we could solve for x, but it won't give us the exact value. It'll give us a decimal, because that's going to be irrational. It's going to have a square root in it. So we're actually going to look at our unit circle, which I don't have up here, but you're going to look on your unit circle for 225 degrees. If you don't have a unit circle, pull it up real quick. But you're going to look for 225 degrees. Remember, sine is opposite over hypotenuse, so sine is the y over 1 on the unit circle, and so it's going to give you square root of 2. It'll be negative, though. If you look at the unit circle, you're just looking at the y value because y is sine. And yeah, so that's how you do that one. Unit circle. Shortcut. So that was E. F, how high above the ground are you after 12 seconds? So I already erased it, but we're going to go back to our formula. 40 plus 35 sine 4.5 times 12. So just more practice with that formula. That's how high above the ground we are at 12 seconds. Okay, so now on the back, as you go on to G and H, so on the test, you're going to get also a table. Can't think of the word for a second. You're going to get a table, and you don't actually have to use the table, but you do have to plot the graph. And this is what we actually are still doing in this new unit. So this should be pretty fresh and not too bad. So it says, when the Ferris wheel stopped the second time, you had friends that were stuck in a position that is only 10 meters off. Oh, sorry, that's for below. Skip that one, we don't go over that on the test. So it says sketch your graph of your height as you go around the Ferris wheel. So go to the second G there, skip the first G. So the second G, you're literally gonna just put it into your calculator. So you're just gonna hit y equals, and then you're gonna do 40 plus 35 sine 4.5 t. You're gonna use that variable button there. And then you'll hit, I'm gonna make sure I'm in degrees real quick. I am. You're gonna hit second graph, you're gonna go to the table, and then it'll give you a lot of X and Y values. So this will plug in lots for you so that you can do a good graph of the sine function there. So that's just calculator work, just plugging it in. And then H is just having you recreate another formula. So it changes up the Ferris wheel a little bit so that you can plug that in and go for it. So definitely study that. It's on the test. If you can do that though, test should be easy because that's a big part of the test. So you got it.